Hello everyone, I hope you all are equally excited to go ahead with this WhatsApp webinar, mammoth WhatsApp webinar on no BREAKO DONTICS. No BREAKO DONTICS is a technique, science of working on a tooth with a proper access opening, good file system and proper endomotor settings to achieve a result that has minimal or no breakage inside the canal. Tooth-related factors include the complexities, the curvature of the canal, calcification of the canal or the pulp chamber, and the position of the tooth. Most economical and best way of not breaking a file is doing a good access opening. And access opening doesn't only mean for the 2% files. Have in your mind that you're going to prepare a 6% taper instrument in the canal. So the complete rotary instrument having 6% taper should be devoid of any contact coronally. For beginners, it is always recommended to do complete deroofing and visualize the dentinal map where you can see all the canals in the single field of vision. But as you evolve in practice, more conservative access opening saves a lot of dentine structure. So visualizing each canal and making it devoid of a coronal contact is a must in a conservative access opening. As we go on to doing conservative access openings, there are more chances of missing out on some canals. So this following slides will be focused on how not to miss a canal. Very important points for the beginners and freshers, that even if you get one canal in the tooth and all the others are calcified or blocked for whatever the reason, by following this laws of symmetry, you will be able to find all the rest of the canals. Few of the points where we can just follow the developmental grooves in the dentinal map or the bleeding points. So wherever we see the bleeding point, there ought to be a canal if we have not touched the floor, mind it. In video, you will be able to see effervescence reaction of sodium hypochlorite. A warm concentrated hypochlorite is placed inside the canal. Wherever we see the effervescent action or the bubbling effect, we can find a canal in that place. This is typically known as a champagne bubble test. First tip for today is remove the dentin shelf. It is creating a double curvature for any of the tooth which is having a secondary curvature in the apical part of the canal. By doing this, as you can see in the above picture, we have suddenly made a file which was going in a curved manner which follows the straight line of the canal with no hindrance on the file at all. I would always recommend a use of Gates Glidden instead of an orifice opener, but it should be used at slow speed and with trained and cautious hand. As you can see in the above picture, our coronal axis and removal of dentine shelf has made the canal very much visible, and only the middle third and apical third remains to be cleaned by our rotary file. So we are reducing the load on our rotary file. Before proceeding to use rotary files inside the canal, you should take care of these three things: that all the calcifications are removed, remove the dentinal shelf that we have discussed, and also if there is an extra canal or entomolaris or any extra root present, please extend your cavity to that particular area so that we can accommodate our rotary file inside it. So coming to file related factors, there are some of the factors which are listed above for which the separation occurs inside the canal. The most common is failure to discard a file. Before jumping to rotary bandwagon, every one of us should understand the weakness of nickel titanium. The following slides will be focused on telling you the weaknesses of NiTi and how we can overcome. Biggest problem with nickel titanium files is that it starts getting microfractures inside its structure as soon as it is introduced inside the canal. As you see in the second slide, the glass shows at each and every step that it is breaking down, but The nickel titanium doesn't show any physical sign of breakage until it separates. Best way to check the microfractures is by bending the niti file every time you use it inside the canal. If it kinks or if it doesn't come back to its original position, then it it should be discarded. On the other hand, best part about the stainless steel files is that it will give you a sign to be discarded as soon as it has got distorted. It will either show a shiny spot or unwinding or too much twisting of the flutes. That is the time you should discard the stainless steel files. We should understand basically how this nickel titanium or why do this nickel titanium instruments fracture inside the canal. There are two distinct modes by which they fracture inside the canal. One is torsional fatigue and second is cyclic fatigue. Torsional fatigue happens when we are doing overzealous preparation. Either we are jumping files, we are about to go for shortcuts, or there is severe curvature or calcification. In this thing, one part of the file gets embedded and it stops rotating, and the rest of the part is still rotating. So the mostly happens in the apical third, and that part gets separated out. The second and most common way by which the file fractures is cyclic fatigue, that now the file is tired or there are too many microfractures present and we are still overusing it. It's the typical abusing of the file or overusing of the file that we do. As you can see in this video, after particular point the file cannot take the stresses on the curvature or on the bend, and that is the point where it fractures. To overcome this kind of cyclic fatigue, you should get over a phenomenon known as ick or phenomenon. I've coined this term because every time I saw a file, I was tempted to use it for one more time because I will be paid more or given more by that file. And it breaks, and you think that, Arey yaar, I was going to throw this away now. So please get over it as soon as the file's 3 or 4 cases are over at the max, or if you are having any calcified, severely curved canals, just don't use that file again and you will definitely your breakage will go down 90%. After knowing different weaknesses of night eye, now we will move ahead that what all things we do wrong while preparing the canal and what things should be avoided. Never force any rotary file inside the canal. Whenever you are using rotary file inside the canal, it should be with a feather touch. As soon as any resistance is encountered, the file should be removed. Never use a file in a dry canal. A proper glide path, proper lubrication, a good EDTA gel will help a proper sliding of the file inside severe curvatures too, and it leads to less amount of friction and stresses developed on file. With advent of newer endomotors, the file breakage due to this factor has gone down drastically because of the apical slowdown function, auto reverse function, adjusting torque, adjusting speed. We can manipulate the files according to your wish and there will be minimum breakage. Before, anthogear used to be with no torque control, no speed control, so there used to be a lot of fractures because of friction generated. Torque is the total force applied by the file while rotating on the lateral part of the canal. You should always understand the higher the speed, lower should be the torque. So newer NITI files, the heat treated files, they use higher speed because more number of cutting blades come in contact as the cutting efficiency of NITI goes down. So more the speed, you always remember for newer heat treated files, you should keep the torque less between 1.5 to 2.2 NCM. After determining the type of curvature and the amount of curvature, we should be taking the following steps to reduce the friction and workload on the file. Whenever doing a cleaning shaping of a curved canal, while doing cleaning and shaping, we tend to straighten out the canal little bit in the process. So always after 2 or 3 files larger cleaning shaping is done, we should recheck the working length of the canal. Always use the flex files, that is 92% files in curved canals. No stiff files should be used inside a curved canal. Also, the newer 1% files, that is Neoprobe, is very efficient in negotiating severe curvatures. Always evaluate the preoperative radiograph and pre-curve the file according to the anatomy of the canal and then introduce inside, so that we don't put unnecessary stresses onto the file and onto the canal. Best way to pre-curve a file is through between two fingers. We can give desired curvature according to the canal, or else for severe curvatures we can use a half round plier. Heat treated file has definitely added a lot to an endodontist armamentarium. The pressure of breaking the negotiating curvatures and to clean the canal the same shape as it was before is the greatest challenge which is solved by the heat treated files. The control memory effect is a very unique thing because it prepares the file according to the canal shape. So we are not preparing the canal according to the file shape, but we are preparing the canal according to its own shape. So it remains a canal centric preparation. The advantage here is because of no active cutting tip, we are not going to transport or ledge the canal. It is just going to follow the glide path. Best we can negotiate the ledges because we can pre-curve the file, as before the rotary files were not able to pre-curve. So any ledges to be negotiated, it was done only by 2% files. Now we can pre-curve it, put it inside the canal, attach it to endomotor and just smoothen out the ledge. These files have a distinct shape memory, so whenever subjected to hot water or dry heat, they will come back to its normal shape. Also, whenever the flutes are unwinded, there's a typical sign that we have to put it to either dry heat or sterilization. If it completely goes back to normal, then we can reuse the file. If it doesn't go back to normal, it is a visual indication that we have to discard the file. So this is the only file available which shows or tells us that now I am done and please discard me. So we'll go on to a cleaning and shipping protocol that I usually follow. It is typically divided into a zone technique, which shows a coronal flare, minimal apical preparation, and then the middle preparation. So in the axis opening with Glades Glidden, we have achieved a coronal flare. With 2% night files, we are bound to achieve a good final MAF, which we need. The only load on rotary file now remains is to prepare and shape the middle third of the canal. So by zone technique, we don't mean that every file system should be followed. We can do a 2% taper preparation in the apical third in severely curved canals and do the flare up of the middle and coronal third with the rotary files. The master apical cone will remain the final master file which was placed till the apex. So if the 2% preparation was done till the apex, the 2% master cone should be selected, and then either warm vertical or cold lateral compaction should be carried out. Here you can see, according to the color difference, we have prepared different areas inside the canal with different files. So none of the file has too much load on it. Now sharing some of the cases done by this file and this technique. That's all from my side, friends. I would like to take this opportunity to thank the whole team of Upgrade Dentistry and Dr. Nisha especially, and hope you all enjoy a break-free dentistry henceforward. Any doubts? I'm here to clear. Now the session is formally open for the question and answers. Kindly go through the seminar first so that the doubts will be cleared at that instance itself.